In this section what we'll do is talk about some of the infrastructure that Erlang provides. So we'll talk about the BIFs, which BIF stands for built-in functions. We'll talk about the libraries that Erlang provides. We'll talk a tiny bit about the manual pages and other sources for documentation. Okay, but let's begin with the BIFs. So these are functions which provide either something that is impossible for you to write yourself, or they provide more efficient implementations of things that it's possible to write for oneself, like the function length, which works over lists. We'll see a demo of these in a minute, but just to give you some examples, you can get date and time, which gives you date, time gives you a much more accurate time. You can ask for length of a list, size of a tuple, and there are various functions for converting between different sorts of types, atoms to list, list to tuple, and so on. These are mostly written in C for fast execution, and conventionally they're regarded as being in the Erlang module. So if you call one of these, you have to name the module as well as the function, so you can simply call them by writing something like date, open close parenthesis, close parenthesis, rather than having to say name the Erlang module. There are BIFs for a whole collection of things. Erlang is a concurrent language, and some of the BIFs cover process handling, port handling, and so on, so for communication. Others allow you to construct and destruct complex data structures. You can do some metaprogramming, we'll see an example of that. You can convert between types. You can gather system information or issue commands to the operating system. You can deal with distribution in Erlang. So in each area of Erlang, there are corresponding built-in functions to allow you to do what you want to do. The manual page gives you, for the Erlang module, gives you a complete list of these. We'll have a look at that in a minute. Also, there's a list of a number of the more important ones in the Erlang programming book. It's important to realize that BIFs have a slightly different behavior from other user-defined functions. As we'll find out later on, Erlang processes are concurrent. They are executed using a scheduler, and what will normally happen is that the process will be allocated a certain amount of resource, and after consuming that resource will be suspended until it's resumed. If a process is executing a BIF, it will run to completion. So it's possible then that a running BIFs inside an Erlang process can mean that that process will hog more of the resources it would were it not to contain BIFs. So other processes will be blocked while the BIF completes. So that's something one needs to be aware of. Okay, what I'd like to do is just run through some examples. There's some examples on the slide, and what I'll do is give you some more examples in the Erlang shell. So what we're looking at here is some of the examples of Erlang BIFs, the date, the time. So we get facilities like that. We get facilities to access lists. So we can take the head of a list, we can take the tail of a list, using head and tail. We can take, let's just do an assignment so I don't have to keep writing it down. We can take the length of a list. Get the length 2, and so on. So we've got those structural devices. We can also take the size of a tuple. Let's just write the size of a tuple. We can ask for the size of that tuple. It tells us there are 2 fields, and we can ask for the element at a certain position in the tuple. And we get the element in position 1 coming out of that. So that allows us to access particular elements from a tuple using a function rather than using pattern matching. So those are all built in. We also have a number of functions which allow us to convert between. So for example, if we take our list, we can convert that to a tuple. And we can also convert a tuple to a list. And these would be impossible to write as functions with Erlang definitions. So there we've got those conversions. So we have a number of, it's possible to convert between many of the types and many others. So that's the general sort of thing that we can do with tuples. That's the general sort of thing we can do with built-in functions. So one particular aspect of built-in functions is that there are certain sorts of metacalls. So it's possible to call the function, to invoke a function, not just simply by applying that function, writing function parentheses, the arguments between parentheses, but it's possible through some bifs, by passing atoms to some bifs, to call functions that way. So there is the bif apply, particularly, to which one passes 3 arguments: module, function, and arguments. It's the function in that module is invoked in that way, with the arguments, however many there are, passed in as a list. Now this, it's possible for any of these components to be evaluated at runtime. So it's possible for you to collect a set of arguments at runtime. It's possible indeed to select a module or function name, which is an atom, at runtime in a similar way. So what I'll do is I'll show you this in action in the shell. And let me just show you an example of a function here. It's the list reverse function. You can see what that does is it takes the list and returns a list with the elements in the reverse order. Let me show you that we can get this in a similar way. By typing the apply function, by invoking the apply function with the arguments lists for the module, reverse for the function, and a list containing the one list 1, 2 as its list of arguments. Remember, there is one argument which is itself a list. It's a common mistake to omit those parentheses. You can see here we've got the same effect. If I show you what happens if you omit the parentheses, you'll see we're getting an error there, because what this is equivalent to is calling list reverse with the arguments 1, 2. And that gives us precisely that same error. So you can see what's happening there is we've called the list with 2 arguments, which are numbers, rather than a single list. But as you can imagine, I could, for sake of argument, do something like this. And I could here pass in an argument which is itself computed, so I don't know what this argument is without doing some evaluation. And what we see there is that we evaluate that final argument, and that becomes the argument to the function. So you can't always tell in advance what those function calls are going to be. And we could similarly create those atoms, list and reverse, by converting from a string, which itself might be computed. So that allows us to do this dynamic programming by constructing arguments or indeed functions or module names dynamically at runtime. And this is a very nice mechanism for doing generic programming in Erlang. So we talked about the built-in functions which conventionally live in the Erlang module. What we're going to talk about now are some of the libraries which Erlang provides. 4 very important ones are listed here. io.erl gives a collection of functions which provide input-output functionality, reading characters, reading lines, and so on. IO format is one of is traditionally the function that's used for producing textual output from Erlang programs. Files.erl gives an interface towards the file system, allowing you to interact with the file system programmatically. Lists.erl is a collection of a huge number of standard list processing functions. We'll take a look at that in a minute. And code.erl provides functionality to load, test, and manipulate code. Beyond that, there are libraries for data structures like arrays, queues, and so on. There are libraries for protocols, so there's a whole collection of libraries. What we'll do in a second is take a look at the Erlang documentation, where you'll get a sense of how many libraries there are and what variety of libraries there are. And these are distributed as part of the standard Erlang distribution. Let's just take a look. Here are some examples of functions from the list library, and let's just take a look at some of those in action. So what we'll do is take a look at some examples of the library functions in the lists library. Let's just set up some example lists first of all. What we can see there is L1, and let's take L2 to be okay, so there we are. We've got two example lists. What can we do with them? Well, we can append them. Now we know in fact how to append. We know in fact how to append two lists. We can do you can use ++, but you can also in fact use the lists append function. Oops. There we are. So we've got the same result as we got using ++. We can take the last element of a list. We can delete an element from a list. And you can see here that's deleted the first occurrence of 3 in the list L1. What could we do if we wanted to delete the last? Well, we could do this. What we could do is reverse L1. We could then delete 3 from that list, and then we could reverse L4. And what we should see there is we've got that original list where we've deleted the last occurrence rather than the first. And you can imagine writing a function where you would say delete the nth occurrence. So you'd pass in an argument where you would want to do that. That just gives a flavour of the sorts of things that we can do with lists. What I would suggest you do is look at the documentation for the lists module. And in fact, what we're going to do presently is look precisely at the manual pages and see where we can find more documentation about Erlang. So we've got the list library. How can we find out more about it? Well, to find out more about the Erlang system in general, we can look at the manual pages. If we're in Unix, we can use the man pages facility there. If we're in a browser, we can access the documentation for the particular distribution that we have mounted on our system, or indeed we can go to the erlang.org webpage to look at the most up-to-date documentation. If we're in Emacs, we can access the documentation that way, and I believe if we're in IDE, we can do the same. What's most useful is the documentation for each of the modules, and what that gives us is an overview of all the functionality that's available in the Erlang system. What I'm going to do now is go to the home page and show you some of the documentation that's available. So here we are at the home page for Erlang, www.erlang.org, and you can see that this contains up-to-date news about Erlang, and in the main column, information about books on Erlang in the left-hand column, and these are down here we see the crucial links that we get for Erlang. How to download the system, FAQs, enhancements, and some getting started material. Let's click on documentation. Now what we get here again is a whole selection of links, but the most important of the links is right at the top. And this is the Erlang OTP release 14 documentation. And what we see here, this is as you would see the documentation on your desktop for the system that you have mounted. There's some basic documentation about the reference manual, links to some books, But where we really get to see the most useful information is in this left-hand column here. Information about applications, which we'll be talking about later on in the course. But for a start, let's click on modules. And what we get here is an alphabetical list of all the modules that are available. So, for example, you can see there's an array module. And what we get in here is an index of the functions. And the functions have a type associated with them, saying that you pass in a function an array and get back an array. So you get documentation for all those functions there. Let's move back to the reference page and let's go down to the Erlang module itself, because that's the one that this gives us a description of the Erlang BIFs, as we talked about earlier. So we have abs, which gives absolute value of a number, down to binary part, down to decoding packets. So you can see that there are a huge collection of element, which extracts an element from a tuple to give you a term. So a huge selection of there's a conversion function for float to list, but these are described with an example, with a type, and so on. So this documentation is really very, very helpful, very accessible, and gives you a guide to what you can find in the Erlang distribution. If we go down a bit further, we should get to the lists module. Again, you can see if you look at the index down here, we have a whole number of functions to merge, to map, to deal with lists that are keyed on certain elements, and so on. So again, these are searchable, of course, using the search function in your browser. So you get a lot of very useful documentation there. Just taking us back one level, you can see that we do have, there's a number of other links there which we would encourage you to explore. But if you like, the applications menu here gives you the standard applications inside Erlang, and the modules particularly are the things that really help you get started.